Hello everyone. Today we will learn about theodolite. So what is theodolite? It is an instrument used to measure horizontal and vertical angles of the designated points from the reference points. So as the definition suggests, ये वो इंस्ट्रूमेंट है जिससे हम किसी भी पॉइंट का हॉरिजॉन्टल as well as vertical angle measure कर सकते हैं from our reference point. It is also used in tachymetric surveying, in which we can identify the elevation and distance of a particular point from the reference point or from the reference direction. So how it is different from dumpy level? Here we can see the movement patterns in theodolite and dumpy level. In dumpy level, we have the freedom of movement only horizontally, but in theodolite, we have the freedom of movement horizontally as well as vertically in theodolite. So that enables us to determine the difference in elevation of a particular point by calculating the elevation as well as distance, which is not so possible in dumpy level. So what are the different parts or components of the theodolite? First of all, we have screws, in which there are foot screws, clamp screws, tangent screws, and focusing screws. So here in the picture, all the arrows of red color are pointing towards certain screws. The bottom of the theodolite, we have foot screws used for the leveling of the theodolite. Generally, we have the setting of 3 foot screws or sometimes 4 foot screws in the theodolite, depending upon the model of the theodolite. Just above that, we have clamp screw, used to clamp holding the movement of the theodolite or to release and freeing the movement of the theodolite in their designated axes. And just above that, we have tangent screw. Tangent screw is used after we have tightened the clamp screw. That is, after we have clamped the theodolite, the movement of the theodolite, and if we need minor adjustments, minor movements, so as to precisely align the degrees, the measurements in the vernier scale and main scale, we use tangential screw or tangent screw. So how do we differentiate a clamp screw from a tangent screw? Generally, we can see that clamp screw are single-headed. They have only one head through which we clamp or release. But tangent screws are two-headed, out of which only one is being used so as to operate the tangential moment of the machine along the main scale. After that, we have focusing screw. The red arrow coming straight from the upward is pointing towards a big screw. That big screw is the focusing screw, used to adjust the movement of objective lens so as to focus on our required point or staff. After that, we have scales. In Theodolite, as we have discussed the movement patterns of Theodolite, there are two scales, horizontal scale and vertical scale. Here in the picture, horizontal scale is denoted by a purple circle and a vertical scale is denoted by a red circle. Both of them consist of a main part of the scale and the vernier part of the scale. After that, we have bubble tube or spirit level, denoted by a blue arrow coming from the right side. It is a check whether the machine is properly leveled or not with the help of foot screws. After that, we have the telescopic part of the theodolite, in which we have eyepiece and objective lens. They are denoted by the green arrows. The arrow coming from the right side is pointing towards the eyepiece. The eyepiece itself consists of a screw which is used to make the crosshair visible so as to target our readings on the staff. As we have mentioned earlier, the objective lens is adjusted with the help of focusing screw. And after that, we have optical plummet, which is denoted by a yellow arrow coming from the left side. It is used to check whether the instrument, the theodolite, is right above the required point or not. So it is used for the centering purpose. So after learning about the components of the theodolite, let's move towards the setup, different types of setups. First we have permanent adjustments. In permanent adjustments, we have vertical axis, axis of plate levels, axis of telescope, line of collimation, and horizontal axis. We have to keep in mind that horizontal axis must be perpendicular to the vertical axis. Then the vertical circle must read 0 when the line of collimation is horizontal. After that, the axis of altitude level or spirit level must be parallel to the line of collimation. The final check is the optical axis. The axis of the objective slide and line of sight should coincide. After cross-checking all these points, we can say that we have completed the permanent adjustments. As the name suggests, permanent adjustments, these adjustments stay for a long time, making it permanent during the course of surveying. After that, we have temporary adjustment, in which there are initial setting, centering, leveling, and focusing. In initial setting, we have to fix the theodolite on a tripod along with the approx leveling and centering over the station mark or the required point. For setting up instrument, the tripod is placed over the station with its legs widely spread so as to support the weight of the theodolite easily. Also, you have to take care that the height of the machine is proper so we can easily adjust and use the machine with convenience. After that, centering. Centering is bringing the vertical axis of the theodolite exactly over the station mark, and we can check it through the plummet, the optical plummet. After that, we have to do leveling to keep the machine vertical and aligned with the force of gravity, avoiding any tilt so as to get the precise measurements of the angles. The final part is focusing. First, focusing the eyepiece, making the crosshair visible, and then focusing the objective lens. The use of focusing screw so as to focus on our required point or the staff measurements. So we got the overview of the setup. Now let's move forward to centering process of the theodolite. So here we can see the machine is set up on the tripod and an arrow is running down from the machine just over our station mark. And just beside that we can see an image of the optical plummet, suggesting that our machine is right over the station mark. Also, the circular bubble suggesting that our initial leveling is correct. This process can be carried out with the help of a plumb bob or a laser, or directly we can use the optical plummet. After that, we move forward to the leveling process of the theodolite. So let's discuss about the leveling in a 3-foot screw theodolite. First we have to do is keep the telescope armored with a bubble tube, the spirit level, parallel to any 2-foot screws. As you can see, the first position of the telescope in this figure is in x-axis, and after that adjustment of the telescope we have to operate the 2-foot screws running parallel to that telescope. So what we have to keep in mind that the movement of the screws should be either inwards or outwards. It shouldn't be both running clockwise or anti-clockwise, but inwards or outwards. Once this has been done, we get the bubble right in the middle part. From this setting, we move towards the next position. The next position is denoted by the green portion of the telescope, which is aligned in the y-axis. And now what we have to do, that the third foot screw, which was left on the first position, we have to operate that third foot screw in any direction so as to adjust the level. It can move clockwise or anti-clockwise according to the requirement. Once both the positions were satisfied and checked with the bubble tube or the spirit level, we can conclude that our leveling process is done correctly. Now, the alignment, the reference points and required points. Now we have to identify our reference direction or a reference point, a benchmark, so we might be able to identify the horizontal angle of our required point from the reference direction, so that we can use that data to plot our required point in a plan or a sheet. After that, we have to do the adjustment in the vernier and main scale. We have to keep in mind that before starting the survey, the vernier scale should be properly aligned with the main scale. The reading should be 0. As we have learned earlier, the vertical circle as well as the horizontal circle must read 0, okay, before we start the surveying process, so as to get the angles accurately. After that, we have to do the focusing of the object. As we can see in the picture that the crosshairs are visible, which is done with the help of screw fitted on the eyepiece. And after that, using the focusing screw, we adjust the objective lens and make the required point or the staff visible to us. We should make sure that the stereo hairs are visible enough so as to locate it on the readings of the staff. After completing all these processes, all these steps, you are now ready to take the readings. Thank you.